We are moving right along, folks. We are on Chapter 4, Part 7. In this video, we're going to look at the use of compound or block statements and how to design and use nested if statements. So here we go. The typical design of an if statement will control only one statement at a time. However, there are times that you're going to need more than one statement to execute if an expression evaluates to true. Well, C++ provides a method that will allow you to execute more than one statement, but treat those multiple statements as if they are grouped together into one large statement. This structure is called compound statements, or a block of statements. Compound statements consist of one or more statements inside of curly braces. Notice our example here. We have a curly brace, several statements to however many you need, and then close the curly brace. Here's a simple example. If age is greater than 18, you have curly braces here, and these two statements are treated as if they're one big statement. You see out eligible to vote and put on the screen no longer a minor. So these two things would be on the screen if their age is greater than 18. Else, if age is not greater than 18, these two statements, because they're in the curly braces, both of these are treated as one large statement for the else. Not eligible to vote and still a minor would be put on the screen. Now let's talk about nested if statements. Remember learning about one-way and two-way selection in a program? Well, sometimes your program might need more than just two selections, right, or two alternatives. When this happens, you can use multiple selection paths by using an if-else statement inside of another if-else statement. This is called nested if statements. When you do this, the else is associated with the most recent if statement that is not already paired with another else statement. Let's take a look at an example. In C++, you cannot have a standalone else statement. If you find yourself with an else statement and no if statement to go with it, you will receive an error. Look at the example here. Assume that score is a variable type int, so this is an integer. Based on the value of score, the following code outputs the grade. If score is greater than or equal to 90, then the grade is A. That's what's going to be output on the screen. Else, if score is greater than 80, the grade is B. Else, if score is greater than 70, the grade is C, and so on. The else will get the most recent statement that's not already been paired. So this else gets this if, because that if is not paired with another else. This else gets this if. This else gets this if, and this else gets this if. Okay. You can have an if statement without an else statement, but you cannot have an else statement with no if statement. So you can have ifs, that's fine, but you cannot have else all by itself. It has to have an if. This program is written using a sequence of if-else statements. It assigns a string value for a month of the year to a numerical value. So let's look. If month equal 1, then you're going to put on the screen January. Else, if month equal 2, then you're going to put February on the screen, and so on, all the way through June. Now, if the C++ program's going through this program segment and it reaches a true statement, so let's say month is 3, so it checks if month equal to 1, oh no, it's 3, so it goes down. Else, if month equal to 2, no, it's 3. So it goes down. Else, if month equal to 3, it is. Puts March on the screen, the program ends. That's how this program segment would work. So keep that in mind when we look at the next segment. After reviewing the previously designed program segment, Let's look at this one. Notice that the evaluation of the if statement continues to the end no matter what the results. So watch. If month is equal to 1, see out January. If month equals to 2, see out February. So it's going to check, but guess what's going to happen? Let's say month is 3. If month equal 1, see out January. No, it can't see out January because it's 3, remember? If month equal 2, no, it won't see out February. If month equal 3, oh, it's going to print out March, but then it still goes, if month equal 4, no, it's not 4. It'll keep checking because we do not have the else statement. The computer has to evaluate every statement and check to see if the statement is true or not. Because of this, it takes longer for this group of if statements to execute. The other program segment on the previous slide only evaluates statements associated with the first true statement it encounters. So in other words, it goes through it until it gets to a true statement, then it's through. This program segment will evaluate every single statement associated with each true condition in the series. So this one goes through every one of them. When you use the else statement, once it reaches something that's true, it thinks it's finished with that group of if statements. C++ uses what is called short circuit evaluation. This is a process where the computer evaluates a logical expression from left to right and stops the evaluation as soon as the final value of the expression is known. In our example for line 1, right here, age is equal to 25. The computer will evaluate the first expression, age, which is 25, is greater than or equal to 21. This is true, and because it only takes one true expression to have a solution for the whole OR expression, then we already know the results. There's no need to evaluate x equal 5. The answer is already known without needing to evaluate it. We know that OR expressions only needs one true to make the whole expression to be true. Well, the computer says this is true, I only need one true, I'm done. It doesn't even look at this other expression. Now let's look at line 2. We're evaluating an AND expression. If you remember, both sides of the AND expression must be true for the entire expression to be true. Therefore, if we assign B to the variable grade, so this is a B is equal to A, this is false. And because it takes both of these to be true with this AND operative, we know that this is false, so the whole thing's going to be false without even looking at x is greater than or equal to 7. The first evaluation determined the result. This is called short circuit evaluation. We have now completed part 7 of chapter 4. I hope you are ready for part 8. That's where we're going to cover comparing floating point numbers, associativity of relational operators, avoiding bugs, and input failure with the if statement.